Given the graph for y equals f of x below, graph y equals 1 over f of x on the same grid. State the domain and range for y equals 1 over f of x. To graph a reciprocal function, y equals 1 over f of x, given a graph of y equals f of x, for each point x comma y on f of x, the point x comma 1 over y is on the reciprocal function. Points for which y equals 1 or y equals negative 1 remain unchanged. Note that taking the reciprocal of 1 or negative 1 will remain as 1 or negative 1. These points are called invariant points. Points for which y equals 0 become vertical asymptotes. An asymptote is a line that a graph will approach but never reach. Note that it is undefined to have 0 on the denominator, so 1 over 0 is undefined. Points for which the absolute value of y is greater than 1, this corresponds to y greater than 1 or y less than negative 1, will correspond to y values between 0 and 1 or between negative 1 and 0. Note, however, that the sign of the y value will not change when taking the reciprocal. Points for which the absolute value of y is less than 1. This means that y is between 0 and 1 or between negative 1 and 0 will correspond on the reciprocal to the absolute value of y being greater than 1. Again, this corresponds to y being greater than 1 or y being less than negative 1. As the absolute value of y becomes infinitely large, for the reciprocal, it approaches 0. This corresponds then to a horizontal asymptote of y equals 0. Note that the line y equals 0 is simply the x-axis. So to plot this reciprocal function, we'll first look at points where the y value is either 1 or negative 1, and these are going to be the invariant points. First of all, at negative 5, comma 1, negative 3, comma negative 1, 3, comma negative 1, and 5, comma 1. We will then look at y values of 0. These correspond to x equals negative 4. This means we have a vertical asymptote of x equals negative 4. And at x equals 4, this is a vertical asymptote of x equals 4. We will then look at a few additional points, mainly at the ends of line segments. We have the point negative 9, comma 3 on the graph of f of x. For the reciprocal, this corresponds to negative 9, comma 1/3. Note we're simply taking the reciprocal of the y coordinate. The point negative 7, comma 3 becomes negative 7, comma 1/3. Negative 2, comma negative 2 becomes negative 2, comma negative 1/2 on the reciprocal. 2, comma negative 2 becomes 2, comma negative 1/2. The point 6, comma 2 becomes the point 6, comma 1/2. 8, comma 2 becomes 8, comma 1/2. And the point 9, comma 4 becomes the point 9, comma 1/4 on the reciprocal. We then connect all of the points, being aware of the vertical asymptotes of x equals -4 and x equals 4, as well as the horizontal asymptote of y equals 0. Any straight horizontal segments for y equals f of x will be straight horizontal segments on the reciprocal graph. Slanted segments on the original graph will correspond to curved sections on the reciprocal graph. Between x equals -9 and -7, we will have a straight line. Then between x equals -7 until we get to the vertical asymptote at x equals -4, we have a curved section, making sure that we go through the invariant point at -5, 1. Then, moving to the right of the x equals -4 asymptote, again, making sure that we approach the asymptote, but this side from the negative y side, we have a curved section, making sure we go through the invariant point at -3, -1, and then going up to the point -2, -1/2. We then have a horizontal segment between x equals -2 and x equals 2 at a y value of -1/2, and then a curved section going through the invariant point at 3, -1, and approaching the vertical asymptote of x equals 4 in the negative direction, since we do not change the sign of the y values when we take a reciprocal. The rest of the graph, the original function is above the x-axis, so the reciprocal will also be above the x-axis. Again, we have a curved section approaching the vertical asymptote of x equals 4 and going through the invariant point of 5, 1. This also then has to go through the point 6, 1/2. We then have a straight line segment between x equals 6 and x equals 8, corresponding to a y value of 1/2. Finally, we now have a curved section, and note that as the y value gets infinitely large, the reciprocal gets infinitely close to 0. This then corresponds to a horizontal asymptote of y equals 0. For the domain and range, first of all, the domain, which are the possible x values. Note that we cannot have any x values less than -9. So we have x greater than or equal to -9. Note also that x cannot be -4 or +4. These correspond to the vertical asymptotes of the graph. And xer, meaning x is an element of the set of real numbers. For the range, we're looking at the possible y values. Looking at the bottom portion of the graph, in between the two vertical asymptotes, the y value must be less than or equal to -1/2. Looking above the x-axis, this corresponds to the right side of the vertical asymptote x equals 4. The y value must be greater than 0. Y must be an element of the set of real numbers.